When your hardware can collect data quickly and easily, you can accumulate a lot of data. But having a lot of data is not the same as having useful, actionable insights. iMotions Lab is a behavior research software platform. It has many versatile analysis tools that help researchers navigate, summarize, and compare groups of data so that you can get from data to insights without extensive coding experience. In this demo, we will go from data collection to insights, giving you a glimpse of what iMotions Lab has to offer. Welcome to an iMotions demo. For this demo study, I looked at engagement while my colleagues played Mario Kart on Nintendo Switch. According to the survey I built using iMotions' advanced survey tool, none of my colleagues participating in the study had tried the new Switch, and most had played Mario Kart. Yes, I said most. I did find someone who had never played Mario Kart before. My study participants had two tasks. In the baseline condition, which we will call the reading condition, participants read a neutral, intentionally boring, AI-generated text about trees. In the test condition, which we will call the race condition, participants played Mario Kart on Nintendo Switch. Intuitively, we expect playing Mario Kart to be more engaging than this particular reading task. We don't really need a study to figure that out. If we just look at participants' faces during each task, we can see that people look more engaged while playing Mario Kart. So why do the study? I want to show you how behavior research tools can be used to quantify complex behaviors like engagement. Although we get the sense from videos that racing is more engaging, it is a bit difficult to pinpoint exactly how we know that. So how do we measure engagement? Engagement is often self-reported. We let players play and then ask them about their experience. This is useful for determining how participants reflect on their own engagement after the task. In this study, we measured players' facial expressions and blink frequency during the task, which gives us a different perspective. Additionally, I want to show that behavior research tools can distinguish between complex behaviors. In this case, we compare attention to engagement. Let's talk more about the setup. For this demo, I used two modalities: facial expression analysis from iMotions Affectiva and a screen-based eye tracker from SmartEye. This allowed me to measure both facial expressions and blinks during both the reading and racing tasks. You may wonder why we would use two different tools to measure engagement. Facial expression analysis codes facial expressions, capturing small movements of different parts of the face that we associate with engaged faces. However, facial expressions can be conscious behaviors. My colleagues can intentionally exaggerate their facial expressions or try to avoid showing much expression at all. This is why having a non-conscious insight is useful. In this case, I measured their blinking. Blink rate tends to decrease with tasks that are more engaging or require more cognitive load. I could measure blinks with just the webcam, but the eye tracker has an additional advantage. Using replay and iMotions, I can verify that my colleagues were actually reading, or at least skimming the text during the reading task, rather than just staring at the screen waiting for time to run out. I can also create dynamic data visualizations of the eye tracking data for individuals or the entire group. Because the screen recording for playing Mario Kart also includes when players select their character and vehicle, I created an annotation so that I can focus on when the participants were racing. Using the data visualization dashboard included in iMotions, we can visualize our data, export graphs, and the data used to create them. iMotion makes it intuitive to create visuals that make for great data storytelling. I choose which groups of data I want to compare. In this case, I want to compare the reading stimulus to the race annotation. Here is what I found. Our facial expression analysis data shows that players appear engaged 10 times more frequently in the racing task compared to the reading task. From the facial expression data, we can see that there are high rates of attention in both conditions. The blink rate data shows that players blink about 60% less in the racing condition. Our analysis supports what we initially observed looking at the webcam video clips. The racing condition is drastically more engaging than the reading condition. Exporting these data to Excel, I can perform some simple statistics. Even though this demo had a small sample size, the difference between the reading and racing conditions is statistically significant in both facial expressions and blinks. This demo study is an example of multimodal research. We use two modalities, facial expression analysis and screen-based eye tracking, to measure engagement. I think this is a good starting place for understanding what basic behavior research looks like. However, this example skims the surface of what iMotions can do for behavior research analysis and what multimodal research can be. For a more complex analysis and more nuanced research questions using more metrics, check out the next video where we explore how crash events in Mario Kart elicit complex emotions and increase arousal.